Hi everyone, welcome back to algebra class. We are going to continue solving equations. This time we will solve multi-step equations. Here are some important vocabulary terms. Term, coefficient, variable, constant, equation, all you should remember from the first day of school. We are now going to include solution, inverse operation, and isolate the variable. So here are the steps that we are going to take when we are only dealing with like terms, and you will be able to do this anytime you see an equation that does not have parentheses. So the first step says, draw your border. So what I mean by border is you're going to draw a line going down your equal sign so that we can keep our work nice and neat. Then it says label your V's and your C's. V stands for anything that has a variable. So in my first problem, 2n plus 4n plus 2 equals 38. 2n has a variable and 4n has a variable. Then it says label your C's, which are the constants. This plus 2 and 38 are constants because they are numbers by themselves. They do not have a variable. Step 2 says combine like terms. So I can only combine like terms if they are on the same side of the equal sign. So if we look on the left side, I have two V's here. I have 2n and 4n. And I'm able to combine these because they both have the variable n. 2n plus 4n gives me 6n. Then I bring down my constants, plus 2 equals 38. I could not combine those because they are not on the same side. The 2 was on the left and 38 is on the right. I cannot combine those. Step 3 says V equals C. I'm trying to get my variable alone. That's why we had that vocab word, isolate the variable. So I want my n to be all by itself. Well, the first person that I'm going to kick out from the left side is the plus 2 because I want my constants on the other side. So now I'm going to use inverse operations, which just means the opposite. What is the opposite of adding 2? Well, the opposite is to subtract 2. And what I do to one side of the border, I have to do to the other side. So I'm going to subtract 2 on the right side as well. 2 minus 2 is 0, so this becomes a 0 pair. Now that is gone, so I'm going to bring down 6n on the left. And then on the right, I'm going to subtract 38 minus 2, which gives me 36. Now again, I'm trying to isolate the variable. Step 4 says get the variable alone. There's still a 6 in the way there. So 6n just means 6 times n. Again, I'm going to use inverse operations. This just means 6 times n. That's why I put that little dot right there just now. 6 times n. The inverse or the opposite would be to divide by 6. And I know that my fraction bar means to divide. 6 divided by 6, that is a 1. N equals 36 divided by 6 is 6. Well, now you're probably thinking, well, the n isn't alone. There's a 1 there. But remember, whenever we were simplifying expressions, I told you guys that's an invisible one. I don't need to keep it there. 1 times n is still just n. So my solution to this equation is n equals 6. Let's do another example. I draw my borders like step 1 says, and I label my V's and my C's. Well, 5x is a variable, and this plus 1x is also a variable. And then the rest are constants. Plus 8, plus 3, and 71 are constants. So I'm looking at my left side of the equal sign, and I have two variables. I have 5x and 1x. Those are like terms, so I can combine them. 5x plus 1x is 6x. And then I also have two constants this time on the right side. So I'm going to combine those. This positive 8 plus 3 becomes a positive 11 equals 71. So now I did step 2. I'm moving on to step 3, V equals C. So I'm on this mission to isolate the variable. The first person I need to move is my constant. I need to move it over to the right side by using inverse operations. The opposite of adding 11 is to subtract 11. What I do to one side, I have to do to the other. This becomes my 0 pair. And now I have 6x equals 71 minus 11 is 60. My last step is, again, I'm isolating the variable. So I need to do inverse operations. This is 6 times x. The opposite would be to divide by 6. What I do to one side, I do to the other. This becomes a 1x equals 10. But we know that that's an invisible 1, so I can remove it. And my solution is x equals 10. Let's do 2 more problems. So again, I draw my border. I label my variables and my constants. Some of you are probably thinking, Miss, I can skip this step. Go for it. Okay, if you don't need to do this step anymore, you can go ahead and skip it. I'm going to keep doing it. Next step is step 2, combine like terms. So I have 2 variables on the left side, 0.2x and 0.4x. I know they're decimals, but it's still the same process. So when I add those, I get 0.6x, or 6/10. And then I bring down my plus 7 equals 82. Now again, I'm on this mission to isolate the variable. So first I need to remove the constant by using inverse operations. The opposite of adding 7 is to subtract 7. What I do to one side, I do to the other. 7 minus 7 is 0, so I have my 0 pair. And I'm left with 0.6x is equal to 75. And again, to finish isolating the variable, I have to use my inverse operation. So I have to divide by 0.6, divide by 0.6. Here's my invisible 1. I get x equals 125 as my solution. Okay. One more problem that only requires us to combine like terms. Again, yes, there's a fraction there. There's 2 fractions there, but it's okay. We are going to follow the exact same steps. I have a variable here and another variable there. Both of those fractions were with x, so they were both variables. And then my minus 5 and 22 are my constants. So next step after I labeled my V's and my C's is to combine like terms. I have 2 x's on the left side, so I can combine them. 11/3 x minus 2/3 x. If you plug that into your calculator, you will see that that becomes 3x. Oh, look how beautiful. The fraction is gone. Then I bring down the minus 5 equals 22. Now the fraction won't always be gone, but in this case it was nice and it became a 3. So now I need to isolate my variable, first by moving my constant to the right by using inverse operations. This time I'm subtracting 5, so the opposite will be to add 5. Please don't subtract 5 because negative 5 minus 5 is not a 0 pair. Make sure you are adding 5. What you do to one side, you do to the other. Now I have my 0 pair because I added 5. On the left, I have 3x. And on the right, I have 27. My last step is to continue to isolate the variable by using inverse operations. 3 times x is the opposite is to divide. So I'm going to divide by 3 on both sides. There's my invisible 1. So I get x is equal to 27 divided by 3 is 9. And so my solution to that equation is 9. So now let's do some problems that involve distributing. If you notice, the steps are exactly the same, but we've added a step at the beginning for step 2, which is to distribute any numbers in front of the parentheses. So if you remember, whenever we simplified expressions, we had to distribute before we combine like terms. So let's go ahead and do this first problem. I'm going to draw my border. Before I can go into labeling my V's and my C's, my variables and my constants, I need to distribute. So for this first problem, I'm going to distribute the 7. 7 times 9 is 63. I have an invisible 1 there with k. 7 times 1k is a plus 7k equals 84. Now I can follow the steps that I did from the first 4 problems. I'm going to label my variables and my constants. So 7k is my variable, and then 63 and 84 are my constants. I'm trying to isolate the variable. So my goal is to get k all by itself. So first I need to move the constant to the right by doing inverse operations. This is a positive 63. So the opposite is minus 63. What I do to one side, I do to the other. This becomes my 0 pair on the left. And now on the left, I have 7k equals 84 minus 63, which is 21. And now again, I'm trying to isolate my k. This is just 7 times k. So the inverse operation is to divide. Here's my 7 divided by 7 gives me my invisible 1. So I have k equals 21 divided by 7, 3. So my solution is k equals 3. Let's do this next problem. 5 parentheses x plus 2 close parentheses plus 10 equals 80. My first step is to distribute. So 5 times 1x, well 5 times 1 is 5, so I have 5x. 5 times positive 2 is a plus 10. I cannot do this. I cannot continue to distribute because that plus 10 is not in the parentheses. So I just bring it down along with my equals 80. So now I can label my variables and my constants. I only have one variable, which is 5x. The rest of them are constants, so 10, 10, and 80 are constants. After distributing, step 3 says to combine like terms, and in this case, I can combine like terms on the left side, which is this plus 10 with this plus 10. So after I combine like terms, I get 5x plus 20 equals 80. So now I need step 4, v equals c. I'm trying to isolate my variable, so I use inverse operations. The opposite of adding is to subtract 20. So what I do to one side, I do to the other. I get my 0 pair here on the left side. So now I have 5x is equal to 60. And my last step is, again, I'm isolating my x. I'm getting it all alone. So I have to use inverse operations. The opposite is to divide. I have x equals 12. All right, let's do 2 more problems. This time, let's do some with decimals. So I'm going to draw my border. And I need to distribute first. So I'm going to distribute this 0.75 with 8x, and I get 6x. Then I distribute over to negative 14, and I get minus 10.5 equals 19.5. Okay, I label my variables and my constants. And after doing so, I notice that I don't have any like terms to combine. So I start working on isolating my variable. So first I move my constant over to the right side by adding 10.5. I get my 0 pair over here on the left. So I bring down my 6x, and it is equal to 30. My last step is to divide by 6. Divide by 6. Here's my invisible 1. X equals 5. Last problem. I draw my border. And then I distribute. So this time I'm going to distribute a -4. Here's my invisible 1 in front of x. So -4 times 1x is -4x. -4 times 3 is -12. I cannot distribute to the +8 because it's not in the parentheses. So I bring it down, equals 36. I label my variables and my constants. -4x is a variable. -12 is a constant. 8 is a constant, and so is 36. Next, I see if I can combine like terms, and I can. Here on the left side, I have two constants, -12 and +8. -12 plus 8 gives me -4. I bring down the 36, and I bring down the -4x at the beginning. So now I go on my mission to isolate the variable using inverse operations. The opposite of this -4 in green is to add 4. What I do to one side, I do to the other. I get my 0 pair. -4x is going to be equal to 40. And again, my mission is to isolate the variable using inverse operations. The opposite of multiplying by -4 is to divide by also a -4. Make sure you have that negative there. So now I get my invisible 1. So I have x is equal to -10, and that is my solution. So that is how you solve equations that involve multi-steps.